This problem asks to find the Maclaurin series for f and its radius of convergence. So our f of x is equal to x squared over 1 plus x. Now we know the form that if 1 over 1 minus x is our f of x, then that is equal to the summation from n equals 0 to infinity of xn. So what we want to try and do first is try to get this equal in that form. So to do that, we'll rewrite it as x squared times 1 over 1 plus x. Now we have a plus x, but we want a minus x. So we can rewrite that as x squared times 1 over 1 minus negative x. So x squared. Now that we have a 1 minus an x, we can rewrite it as the summation from n equals 0 to infinity over x, which is negative x, to the nth power. We can now distribute this. Well, first we'll rewrite the negative xn as negative 1 to the n times x to the n. Now we'll distribute the x squared into the summation. So we'll have negative 1 to the n, and since we have common bases, we'll add the exponents, so it'll be x to the n plus 2. So that's our Maclaurin series. Now we want to find the radius of convergence. So to do that, we'll use the ratio test on our Maclaurin series. So the ratio test is the limit as n approaches infinity, the absolute value of a of n plus 1 over a of n. So with our Maclaurin series, we'll have the limit as n approaches infinity. The a of n plus 1, we just add plus 1 to our n's. So it'll be negative 1, n plus 1, x, n plus 1, and then we have our plus 2. All over the negative 1n, x to n plus 2 for here. And we can cancel a few things out. Just by using properties of fractions, when we have similar bases, the exponents can be subtracted. So when we subtract n plus 1 minus n, we're just left with 1. And since it's absolute value, this negative 1 becomes a positive 1. So we'll rewrite that as the limit as n approaches infinity, absolute value, x, n plus 1 plus 2 is n plus 3 over our x, n plus 2. Again, with the properties of fractions, we have our similar bases. So n plus 3 minus n plus 2. We're left with 1. So x to the first. So that gets us the limit as n approaches infinity, absolute value of x. Now since our limit is in terms of n approaching infinity, the absolute value of x isn't affected, so our answer is absolute value of x, and we want it to be less than 1, which means that our radius of convergence r is equal to 1. So again, the Maclaurin series of our function f of x equals x squared over 1 plus x is the summation of n equals 0, or the summation from n equals 0 to infinity of negative 1 to the n times x to n plus 2, with the radius of convergence of 1.